right, today we are going to talk about identifying proportional relationships. So we'll get going on the video here. Remember, if you need to pause it to make sure you get everything, please go ahead and do that. If there's something you didn't quite get, make sure you rewind and go back and take a look at that. So to get started here, we've got a brand of cheese costs $5 per pound. So the table's telling me if I buy 1 pound, it's going to cost me $5. Okay, if I buy 2 pounds, it's going to cost me 10. If I buy 3 pounds, it's going to cost me 15. So I have to decide if this is a proportional relationship. Now, one thing we're going to do here is, again, this top row, we're going to call that X. The bottom row, we're going to call it Y. So when you look at what they've given for letters, the W is like our X, the P is like our Y. Now, to determine if something's a proportional relationship, what has to be true is that if I take the Y over the X, it's going to equal the same thing every time, which in this case we're going to call it K. And that's our constant. So my first one here, I would take the 5 over 1. Well, 5 over 1 equals 5. Then I would try the 10 over 2. Again, we're doing Y over X. 10 over 2 also equals 5. And then lastly, I would try the 15 divided by 3. Well, 15 divided by 3 also equals 5. So since they all equal the same thing, Y over X equals the same number for all of them, we would say yes, this is a proportional relationship. Okay? Now our constant of proportionality, again, we're using, when we do Y over X equals K, our constant is this. So in this case, our constant for each one of these was 5. So in this case, Y over X always equals 5. So 5 is your constant of proportionality. Okay? And then what we do is we write a formula. Well, here's how this works. Since we know that Y over X has to equal K, our formula is going to start with Y, and it's going to go Y equals. So to get this to say Y equals, what I would do is multiply this by X. If I do that to one side, I got to do it to this side. So my X's would cancel out, and what I'd be left with here is Y equals K times X, which is KX. So to write my formula, the only thing I need to substitute in there is my 5 for my K. So now this one becomes Y equals 5X. Now since in this problem they're talking about price and they're talking about weight, if we use the P and the W, this would be P equals 5W, because we're taking 5 times the weight to get the price. Okay, so there we go with that example. All right, our next example, again, we have a table here. We've got X and Y. And the question is the value of Y over X constant? So what we're going to do is we're going to take Y divided by X for each one. So 8 divided by 2 is 4. If I take 45.2 divided by 11.3, I also get 4. And then the last one here, if I take 82.46 divided by 21.7, I actually get 3.8. Okay, so is the value of Y over X constant? Our answer to that would be no. Okay, it has to be the same for each one. So Y over X does not equal the same for each one. Okay, and as soon as you find one that's different, that's all you need. As soon as one doesn't work, is different from the other ones, then it's not proportional. That's all you have to do. So what you have to remember here for all this is that K is the constant, and y over x has to equal K and y equals K times x. Okay? This has to work. Okay, if this doesn't work, it's not proportional. All right, so we are going to move on to the next part here. All right, you got a few slides here. Just kind of going over what we've already gone over. If you want to pause and take a look at those, please feel free to do so. Okay, but what we're going to get started on here is these example problems. So for number one here, if I take y over x in this table, 5.25 divided by 3 is 1.75. And if you do this for each one, what you're going to find is you are going to get 1.75 for each one of them. So that means my k right here is 1.75. So to write my formula, I'm going to have y equals 1.75 x. Again, all I'm doing is inserting the 1.75 in for k into my formula. All right, for the other one, if we take 2.4 divided by 3, we're going to get 0.8. And what you're going to find out is that for each one of these, when you divide them, you are going to get 0.8. So again, my k is 0.8. So I'm going to take that 0.8, put it in for k, and I'm going to get y equals 0.8x. Okay, so there we have our formulas for those two tables. All right, next we're going to look at these four tables here. And I've already got them worked out, but if you look at table A, if we take y over x for the first one, 1.06 divided by 1, we'll get 1.06. But as soon as we go ahead to the next one here and do 1.2 over 4, well, that's 0.3. Now, I've got two different values there for y over x, so I know that that's not a ratio table. For B, if I do y over x, every time I'm going to get 26. So 13 divided by 0.5 is 26. 26 divided by 1 is 26. That's going to be the same for each one. For letter C again, for the first one, y over x, 5 divided by 1 is 5. But as soon as I do the next one, 8.5 divided by 2, I get 4.25. So that tells me it's not a ratio table because I got two different solutions for k, and I can only have one. Letter D again, if you notice there, it's going to be 2.2 each time. 4.4 divided by 2 is 2.2. 11 divided by 5 is 2.2. It's the same for each one. So k is constant for table D. So going down to part A there, write a formula in the form y equals kx. So again, we're just substituting that constant in for k in the formula. So for letter B, it would be y equals 26x. And for table D, we would get y equals 2.2x. Now moving on, it asks us to find those missing values for B and D. So for B, I'm missing a y value here, but I know the x for that is 2.0. So I'm just going to substitute that in for x, and I'm going to get 26 times 2 is going to be 52. So I can go ahead and put that 52 into my table right here. Now for the table D, we have the y value, and we need to figure out what the x is. So I'm going to put that 26.4 in for y, and I'm going to solve for x. Now to solve for x here, the opposite of multiplying by 2.2 is dividing by 2.2. And when I do that, I am going to get 26.4 divided by 2.2 is going to equal 12. And the 2.2's cancel over here, and we're left with the x. So 12 equals x. That goes in to my table right here. The next thing we're going to look at here are the graphs of those four tables. So we're going to see how graphs determine if something's proportional or not. So we already said table A was not proportional. If we graph it, what we see happening is that the points do not line up. So if something is proportional, the points are going to line up when you graph it. So table or graph for A, I know it's not proportional right away because the points are not lined up. Now table B, we said that we determined that that was proportional. If I look at the graph, what happens is the points all line up, as you can see with the dashed line, and they go through the origin, which is 0, 0. Both of those things have to happen on the graph for it to be considered proportional. If you look at graph C, the points all line up, but it doesn't go through the origin. Okay, so that dashed line I put on there, it doesn't go through the origin, so it's not proportional. Again, both things have to happen. They have to line up and go through 0, 0. So in graph C, they line up, but they don't go through 0, 0, so it's not proportional. Graph D again, remember table D, we said that that was proportional, so when we graph that table, we see that the points all line up, and we see that the dashed line goes through the origin 0, 0. So that's how we know on a graph. All right, to wrap this up and make sure you get the main points here of this lesson, 5 is just asking how you can determine whether two quantities are proportional. So the main thing here to look for is that if y over x equals k, if that's the same for each pair, then it's proportional. Number 6, it's talking about the graphs and being proportional. Again, the points in a proportional relationship will line up and go through the origin, which is 0, 0, when you make the graph. Number 7, it's asking if y or x, if one of them equals 0, why does the other one have to equal 0? So why does it have to go through the origin 0, 0? Well, if x equals 0 here on the right, if I put 0 in there, k times 0, well, anything times 0 is going to be 0, so y will equal 0. If you look at the one on the right, if we put 0 in for y, 0 would equal k times x. To solve for x, I'd have to divide by k. Well, I'm doing 0 divided by some number, but 0 divided by anything is 0. So x would equal 0. So it works both ways. If x equals 0, y will equal 0. If y equals 0, x will equal 0. Okay, and the last thing here to close this out, what steps would you take to determine that a set of data is proportional? Well, on a table, if y over x equals k for each one, that's going to be a proportional ratio table there. And on a graph, again, the points must line up, which means that's called linear when they line up, and they must go through the origin 0, 0. Okay, make sure you have everything complete here. Show this to a staff member in the room, and we'll get you your homework, and you'll get going.